If you buy a hybrid car thinking it's an automatic ticket to saving money, you might be setting yourself up for an expensive mistake. If the engineering under the hood doesn't match your specific commute, you are going to waste your investment. Look at the spec sheet for almost any hybrid on the market, and you will find the exact same 3 core ingredients: an internal combustion engine, an electric motor, and a battery. But possessing those parts isn't what dictates performance. How engineers physically arrange them determines how the car feels when you step on the gas, and more importantly, how much fuel it actually burns. The distinction really comes down to one mechanical question. Does the gas engine physically turn the wheels, or does it exist purely to generate electricity? Based on that answer, the entire market is split into 3 competing architectures: parallel, series, and series parallel drivetrains. Choosing between these 3 options means navigating a strict engineering trade-off. You have to decide whether you want to prioritize massive electrical storage or raw mechanical efficiency. Understanding how these internal architectures manage power is the only way to guarantee a return on the thousands of extra dollars you pay up front for a hybrid. Let's start with the parallel hybrid. The engineering priority here is maximizing raw mechanical efficiency, getting power to the pavement as directly as possible. Look at this diagram. In a parallel system, the internal combustion engine is connected directly to the wheels, alongside the electric motor. The benefit is mechanical power transfers directly to the pavement without changing forms. This makes it highly efficient at sustained highway speeds. It also creates a structural cost advantage. Because the gas engine and the electric motor share the workload of moving the car, manufacturers can equip parallel hybrids with a much smaller, lighter, and cheaper battery pack. But this direct connection introduces a concept called mechanical coupling. Because the engine is permanently linked to the wheels, the engine's RPM is physically forced to match the speed of the road. If you are constantly starting and stopping in heavy traffic, the engine is forced to rev up and slow down right along with you. It can't settle into a steady, optimal RPM, which drags down your fuel efficiency in the city. Parallel hybrids sacrifice urban electrical performance in order to completely avoid energy conversion losses out on the open road. The series hybrid takes the exact opposite approach. Here, the engineering prioritizes electrical energy storage. In this design, the gas engine is physically disconnected from the wheels. Its only job is to turn a generator. Because the engine doesn't react to the car's speed, it sits at peak efficiency RPM indefinitely, operating entirely as an onboard power plant. When you're crawling through unpredictable stop-and-go city traffic, this disconnected design delivers phenomenal fuel efficiency. The electric motor handles the constant speed changes, while the gas engine hums along perfectly undisturbed. But relying 100% on that electric motor for traction requires serious hardware. Series hybrids need a massive, heavy, and highly expensive battery pack to handle the full load of moving the vehicle. This setup also introduces double conversion loss.
The mechanical energy from the engine is converted into electricity by the generator, and then converted right back into mechanical energy by the motor at the wheels. Every time energy changes forms, you lose a little bit of it. If you try to maintain high, sustained highway speeds, those double conversion losses accumulate and heavily penalize your fuel economy. You can think of a series hybrid as a fully electric vehicle carrying its own highly optimized gas-powered charger. They excel in urban environments, but struggle on the open highway. If you want to eliminate the compromises of those 2 designs, you have to engineer a system that does both. That is the series parallel hybrid. It is the exact dual architecture that the Toyota Prius famously popularized on a global scale. This system dynamically switches roles based on what you need. It acts like a series hybrid at low speeds to save fuel in traffic, and then operates as a parallel hybrid at high speeds to avoid conversion losses. The crucial component here is the planetary gear set, a device that seamlessly splits power between the engine, generator, and wheels. By constantly splitting that power flow, the engine operates in its optimal efficiency range more often, maximizing fuel economy across almost all conditions. The design is robust enough that even heavy industry uses variations of it. Vehicles like off-road wheel loaders rely on this architecture to handle massive torque demands while managing long periods of engine idling. But merging 2 systems comes with significant drawbacks. You add an extra electric machine, a complicated gear set, and massive computational complexity. That means extra weight and the highest purchasing cost. Series parallel drivetrains offer the ultimate versatility, allowing the car to adapt to almost any environment, but they force you to pay a steep premium for that engineering complexity. So, which one should you buy? The truth is, the best hybrid depends entirely on your daily driving environment. To make the right choice, we can map these architectures into a simple decision matrix based on your habits. First, consider the city commuter. If you spend 80% of your time in low-speed, stop-and-go traffic or dense urban grids, you want a series hybrid. The phenomenal low-speed efficiency of relying entirely on the electric motor vastly outweighs the upfront cost of the larger battery pack over the car's life. Next is the highway cruiser. This is the driver logging long distances at sustained high speeds on the interstate. For this profile, the parallel hybrid is the clear winner. You rely on raw mechanical efficiency to completely bypass electrical conversion losses at high speeds. And because you don't need massive electrical storage for open road driving, you also save thousands of dollars up front on a smaller, lighter battery. Finally, there is the one-car household. If you need total flexibility, handling the urban school drop-off on Tuesday and a cross-country road trip on Saturday, you need a series parallel hybrid. It automatically adapts to any environment you throw at it without sacrificing efficiency, making it the only choice that truly covers every base. Hybrids only save you money if they operate in the conditions they were engineered for. Maximizing your return on investment requires matching the physics under the hood to the reality of your daily commute.